Hey everybody, it's Mr. Carr again, and today we're going to be talking about 6.2, classifying triangles by their sides and angles. Okay, so when I say sides and angles, that means we have two ways of classifying. Every triangle can be named with two names, one based on sides, one based on angles. So we have three types for when we classify triangles by sides. If we have zero congruent sides, that is called a scalene. Okay. If we have at least two congruent sides, that is isosceles. And then if we have all three that are congruent, that's an equilateral. Okay. And just like I mentioned on the previous video, when I have an isosceles like this, and notice how it says at least two congruent sides, that means technically speaking, an equilateral triangle does have at least two congruent sides if all three are congruent. So an equilateral is also considered an isosceles, but an isosceles may or may not be an equilateral. Okay. Um, the next one is to classify triangles by their angles. Okay. So we can have either all three are acute angles, which means that makes it an acute triangle. Pretty straightforward. I like to actually jump over to obtuse right now. This one has one obtuse angle. Okay. So that means that is one angle that is greater than 90 degrees. So that's going to be kind of like I like to consider my opposite of acute. So that's going to be an obtuse triangle. Okay. If I have exactly one right angle, that makes it a right triangle. Okay. One last one is if all three angles are congruent. So this is actually like our equilateral, but it's going to be equiangular. Okay. So when I name these triangles, every triangle can have one name from each section. So I name a triangle by being it could be an acute scalene, okay, or it's a right scalene, or it's acute isosceles. The one thing that we're never going to do is we're never going to put equilateral with any of these three. These two have to go together. If it's equilateral, it's equiangular. If it's equiangular, it's equilateral. There's no option there. So I wouldn't say, technically, I could say an acute equilateral, but this is more descriptive. Okay. So these two will always go together, equilateral and equiangular. All right. So just a couple examples here. Two angles in a triangle have the following measure. Measure angle R is 60, measure angle F is 30 degrees. Which descriptions match this triangle? Select all that apply. So just like I always say with this, when in doubt, draw it out. Okay. We have a triangle. I've got 60 degrees and I've got 30 degrees. Okay. So there's my 30, there's my 60. This is angle R and this is angle F. Okay. I don't know what the third letter is, so let's go with A. So I can make triangle ARF. Triangle ARF. Little dog humor. Yeah. Okay. So now I want to apply my properties from before. We have a triangle. So that means this adds up to 180 degrees. So I'll call that X for now. 30 plus 60 plus X is going to equal to 180 degrees. There's my interior angles theorem for triangles. So 30 plus 60 is 90. Oops. Subtract that 90 over, and I get X is 90 degrees. Well, that means I know I have a right angle. That's what that means to be 90 degrees. It is a right angle. So I know that one. I'm going to go here and pick that one. So that's my angle classification, but let's look at sides. Is there enough information to say that I have zero congruent sides, two congruent sides, or, well, not all three congruent sides? So it's either going to be scalene or isosceles. Well, if I look at the scenario, one thing that I want to notice is that 30 and 60 are different angles. We know from before an isosceles triangle, if they have two sides that match up, then they have opposite base angles that also match up. Well, I don't have matching angles. All three angles are different. So that's actually one neat thing about this. If there are zero congruent sides, there are also zero congruent angles. Okay. So if you have a scenario where you have three different angles, you know it's also scalene. Same thing with isosceles. If there's at least two congruent sides, there's also two congruent, just do a symbol, angles. That's just a little bit extra information to help us with our classifications. So I can also choose C here. This is a right scaling triangle. All right, given measure of angle B is 2 times measure of angle A, and measure of angle A equals 40 degrees. Classify and sketch triangle ABC. All right, so we got triangle ABC. So, I don't know. It doesn't really matter how I draw it. I kind of drew it as an equilateral, but it's fine. So we got ABC. Angle A is 40 degrees, and measure of angle B is 2 times measure of angle A. So 2 times 40 is going to give me 80 degrees. Okay, just like before. I have 2 of my angles. I need to find out the third angle. So I got 40 plus 80 plus, we'll call it X down here, equals 180. That's 120 plus X equals 180. And then subtract that over, and I get 60. So this is 40, 60, and 80 degrees. All 3 angles are less than 90 degrees. That means that it is an acute triangle. All 3 angles are different, so that means that it is a scaling. Whoops. Scale. Oh no, I had that right. Scale. So this is an acute scaling triangle. All right. And given triangle ABC, angle A and B are congruent, and measure of angle C is 20 degrees. So one thing I know is that these 2 are congruent. So we know it's at least an isosceles. Could it also be an equilateral? No. Angle C here is 20 degrees. For it to be an equilateral, remember from the previous video, all 3 angles have to be 60 degrees. So we know I can actually just go ahead and say isosceles here. I have 2 congruent angles. I know it's an isosceles. But now I need to know if it's an acute or an obtuse. So if I do this, I'll just quickly sketch this out. What am I doing here? Nope, I won't do it this way. Sorry. Make it nice and skinny at the top here. Okay, so that's angle C, and that's 20 degrees. And then we got these 2 are congruent. So I'm going to call them, we'll do that and that. We'll call it X and X. They match up. Okay, and that's A and B. So I can do X plus 20 equals 180. That's 2X plus 20 equals 180. Subtract the 20 degrees over, so I get 2X is equal to 160. And then divide by 2, and that X is equal to 80. So these are both 80 degrees here. Meaning I have an acute isosceles triangle again. Or I have acute again. So I have an acute isosceles here. Okay. So this is another scenario that, just like we did, I've given you all the, I've shown everything here. So again, we're going to apply those interior angles. So we're going to take 4X plus 6X plus 80 and set that equal to 180. Okay, so we got 4X and 6X come together as 10X plus 80 equals 180. Subtract the 80 over so that I have 10X equals to 100. And then divide by 10 so that X is equal to 10. All right, so I have the X value. When I plug it in here, that's 4 times 10 is 40. Plug it in here, 6 times 10 is 60. So we have 40, 60, and 80. All 3 angles are different. This is a scaling triangle. All the angles are less than 90 degrees. It is an acute triangle. All right, one last example for my video here. And that is also going to be doing a, okay, not a triangle, a triangle. We're going to classify a triangle given these coordinates. So what we want to do is we can actually figure out, for now, all you're going to be able to do is figure out the side classification. We're not going to worry about angles right now. Okay. Sometimes there's ways to do it, but for us right now, we're not going to do it that way. Okay. So we got A is at 2, 3. 1, 2, 3. Here's A. B is at 6, 3. So 1, 2, 3, 4, 5, 6, 3. And C is at 4, 0. 1, 2, 3, 4. Okay. So here's my triangle. So to figure out what it is by sides, I'm going to look at, like, let's start with the easy one. I just need to find the distance of each of these. So we're actually going way back to distance formula, which, if you remember, is this. X2 minus X1 squared plus Y2 minus Y1 squared. Okay, you can either do distance formula, or you can do, let's do this, little mini right triangles there. Okay. So we can do Pythagorean theorem and just do it for like, where it's leg, 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 hypotenuse. It's up to you how you want to do it. But I just want to remember, just bring that back because this has been a while since we've done these. All right, AB is easy. I'm going to just count that out. 1, 2, 3, 4. Okay, now I'm going to do AC and BC there. Well, one thing, I'm just going to do Pythagorean theorem because that's my preference. So I'm going to kind of recreate this little right triangle here for BC. So that's a leg of 2. So it's 1, 2, and then 1, 2, 3. Okay, and then this is the length of BC. So I'll just call that X for now. So 2 squared plus 3 squared equals X squared. 4 plus 9 equals X squared. 13 equals X squared, square root that, and that's the root of 13. Honestly, I'm just going to leave it as root 13. There's no real need to, I could do the decimal if I really wanted to. It's going to be probably about 3.7-ish, okay? It's not really a concern because all I need to do is classify by sides. So I just wanted to see if this matches up to anything. So let's go ahead and look over at AC now. If I look at that triangle, you notice it is 1, 2, 1, 2, 3. It's the same exact scenario as this. So I feel confident that this is going to be root 13, as so is this. Okay, so since I have two angles that are the same, or sorry, two sides that are the same, I now can show this is an isosceles triangle. Okay, to me, my first initial guess would be that this looks like an equilateral, but we just showed using our distance formula that these are equilateral or isosceles, not equilateral. Okay, so that's it for classifying. Again, real quick summary. 2 ways to classify: sides, angles. Okay, so some information we can actually gather from each. So if we can get no congruent sides, we can also say there's no congruent angles. Or we can also say if there's no congruent angles, there's no congruent sides. If there's 2 congruent angles, we can say that's also isosceles. Okay, equilateral is equiangular, and vice versa. So that's it for 6.2. We'll finish up with 6.3 soon. Talk to you later on this one. All right. Have a nice day.